Hello everyone. Today we are looking at arithmetic operations under number base. And under this very operation, we are going to be looking at addition and subtraction using analytical method. Now, in the previous exposition, we worked on this using direct method. So today we're going to be looking at how we can use analytical method. So yeah, this is an example. Now, this analytical method is a method that can work for both equal bases and unequal bases. And when the bases are the same, as I said, the red method is the best. But this very method is not limited. If the bases are the same, it's good to go. When the bases are different, it will also be used. So let's see what I'm going to do. Now, the first thing I'm going to do is to convert each of this given stuff to base 10. Any number in base 10 is an ordinary number, don't forget. And that's why you have to go through the previous expositions. If you're just seeing this very channel for the first time for you to understand this 100%. So let's work on this first. Let's convert this, each of them first to base 10. You're going to be using repeated multiplication method to save our time. 3, 4, 2, 1 in base 5. You're going to times and add because each of these are whole numbers. So you're going to times, start with the first, the point is here, start from the other side. 3 times 5 is 15. So 15 plus 4, don't forget, you know this already, you times only with the base. That's 19, 19 times 5, that's 95. 95 plus 2 is 97, 97 times 5. 5 times 7, 35, I have 5, keep your 3. 5 times 9 for the 5 plus 3 is 48, 485. 485 plus 1, that'll give us 486, we're done with that. It's already in base 10, and these are an ordinary number. So let's work on the other one. The other one is 4432. You're going to be doing the same thing. 4432 in base 5 to be converted to base 10. So 4 times 5 is 20. 20 plus 4 is 24. That's 24 times 5. 5 times 5 is 20. 5 times 2, 10 plus 2, 12. 120. 120 plus 3 is 123. So 123 times 5. 5 times 3 is 15. I have 5, keep your 1. 5 times 2, 10 plus 1, 11. I have 1, keep your 1. 5 times 1, 5 plus 1, 6. 615. Then 615 plus very last stuff plus 7 plus 2, that's 617. So we're done with this 2. They're already converted to base 10. They're ordinary numbers. So the next thing you do is to add this ordinary numbers together. So that's 486 plus 617. We're adding them together. Ordinary numbers. 6 plus 7 is 13. Keep your 1, 1 plus 8, 9 plus 1, 10. 1 plus 4, 5 plus 6, 11. So we have 1103. And for the fact that what we're working on are both in base 5, we're going to be converting this back to base 5. And how do you do that? How do you convert base 10 to base 5? You do that by dividing. So you're going to do that very quickly. 1103 divided by 5. You state out your remainders. 5 in 1, 0, remainder 1. 5 in 11, 2, 10, remainder 1. 5 in 10 is 2. No remainder. 5 in 3, 0, remainder 3. So keep dividing until you get to 0. 5 in 2, 0, remainder 2. 5 in 22 is 420. Remainder 2. 5 in 20 is 4. No remainder. 5 in 44 is 8. 40, remainder 4. So next 5 again. 5 in 8, 1, remainder 3. One more. 5 in 1, 0, remainder 1. State your answer up in the base. So this 13403 base 5. And these are to use the analytical method to solve this. As easy as ABC. So convert each of them first to base 10. Then once you don't get your answers in base 10, they become ordinary numbers. Then you add up. Once you're done with that, convert to the base given. Now let's try this out. Let's look at this. Now solve. This method is not limited. We could use this method to solve anything. Actually, we can use this method to solve anything. 357 base 8 minus 531 base 6. Leave your answer in base 13. As you can see, this looks like looks like an enigma. We are working on two different bases, numbers with the two different bases. This 357 base 8 minus 531 base 6. They're different. So how do we go about this? How do we work on this? We can't use your direct method. So, and that's why this method is apt. It's the best fit method for this. So the first thing I have to do is to look for a way to convert this to base 10. This also to base 10. So when you're done with that, you end up having ordinary numbers. You subtract the answer you get, then you convert it to base 13. So let's dash directly to work. 357 base 8, first to base 10. Repeat the multiplication method. You times and add. 3 times 8 is 24. Plus 5. 29. Times 8. 8 times 9 is 72. 2 keep you 7. 8 times 2 is 16. Plus 7 is 23. 2 32 plus 7. That will give us 239. So we're done with that. So next 531 in base 6 times and add. 5 times 6 is 30. 30 plus 3 is 33. 33 times 6 18 198 plus 1 199. Well, look at what we've got. So the next is you're going to use this to subtract this. Since they are ordinary numbers now, they are both in base 10. 239 minus 199. 9 minus 9 is 0. 3 minus 9 impossible. Borrow 1 from here 1. Put here 30 minus 9 is 4. 1 minus 1 is 0. So we got 40. So you're going to convert this 40 to base 13. Don't forget they are both different bases. So you're going to convert this to base 13. That's why the answer is the Libra answer in base 13. So quickly let's do that. You're going to divide. We use our 13 to divide the 40. One after the other, we're going to do that a couple of times. 13 in 40 is 3. Remember 1. That's 13 times 3, 39. 13 in 3 is 0. Remember 3. We're done. So that's 31 base 13. That's our final answer. So yeah, we have a couple of take homes. So you're going to try this out for me. Try this out for me. Now solve this for me. Solve 2 5 7 3 in base 8 minus 2 4 3 5 2 4 3 5 in base 6. Leave your answer in hexadecimal. Leave your answer in hexadecimal. So you're going to be drawing the content for today's exposition. At this very junction, you're drawing the content on today's exposition. So this is what you're going to do for me. If you found this resourceful, please subscribe to the very channel and share this exposition. See you in the next exposition. Thanks.